Welcome back. Today we will solve the problems by using mesh analysis. Let's start it. As you know, for the mesh analysis, for each loop we need to assign the current. For the first loop, we will assign current as I1. For the second loop, we will assign the current as I2. And as per the direction of the current, we need to assign the sign for each resistance. For 40, it is plus minus. For 2.4 kilo ohm, this is plus minus. And as per the current I2 for 2.4 kilo ohm, here it is plus and here minus. And for 1 kilo ohm, this is plus minus. And for this 500 ohm, this is plus and minus. Now we need to find the equation by using Kirchhoff's voltage law. For the first loop, already we know the current value, that is 2.5 milliampere. The direction of this current and I1 current both are same, so that we can conclude that I1 is equal to 2.5 milliampere. In this problem, we need to find the IA value. So IA is equal to I2 minus I1, not I1 minus I2, because IA direction and I2 direction both are same. So because of that, IA is equal to I2 minus I1. And for the next loop, we need to find the equation. That is 2.4 kilo I2 minus I1 plus 1 kilo I2 minus 150 IA plus 500 I2. But from the first equation, we know that IA is equal to I2 minus I1. So put this one in here. As we already know, I1 is equal to 2.5 milliampere. So put this equation in equation number 2. So we will get I2 is equal to 1.5 milliampere, and we already know that I1 is equal to 2.5 milliampere. And from the equation number 1, we know that IA is equal to I2 minus I1. Therefore, IA is equal to 1.5 milliampere minus 2.5 milliampere. So this is equal to minus 1 milliampere. I hope the concept of mesh analysis is clear. If you like the video, do like and share with your friends. Press the subscribe button for more videos. Press the bell icon for regular updates. Thank you for watching.